Hi there. I'm John Price. I'm with Digame Systems, and I thought I'd talk to you a little bit today about how we're using MQTT, in particular the Eclipse Foundation Sparkplug specification, to enable RFID readers to be a lot easier to use. And I'll show you that now. Digame, my company, is a small software consulting company. We specialize in Internet of Things applications, and so we help folks develop products. And the work we've done ranges from a wide variety of things, but basically we focus a lot on wireless technology, particularly RFID, NFC, and Bluetooth. And so here, the background is a recent project with a company called SensThys out of Cupertino, California. They make a really slick RFID reader with antennae that's integrated together, and it has neat networking capabilities. The one I just clicked here is Alien RFID System. I've worked with those guys in the past. I actually ran their software group for a while. And the Digame team has worked with NXP Corporation around both their NFC product line and their UHF RFID systems, IC systems, that is. And we've done some work with companies out of Canada, in particular Geotab, that does vehicle tracking. And so that was an interesting application of both RFID and geolocation. Finally, I want to turn back to SensThys and talk a little bit about the most recent project we've done, where we helped launch their new family of readers, in particular the Extreme platform, which is shown here. This is a Linux system / RFID reader that's designed for industrial environments. So it's really tough, and you can hit it with a hose. I mean, it's environmentally rugged. So Sparkplug, as I mentioned, is a standard out of the Eclipse Foundation, and what it is it's based on top of MQTT. So you can't really talk about Eclipse without talking a little bit about MQTT to explain kind of what it's bringing to the table. And so MQTT used to be known as message queuing telemetry transport. Currently, it just means MQTT. The party line is that we don't have a particular phrasing for the acronym. It's just what it is. So it's something to know. MQTT is a publish and subscribe model for how machines talk to each other. And so the concept is you have some kind of network service, which we call a broker, that things connect to, and they make requests for information or subscribe to certain kinds of information, as well as publish information on topics. And so when information comes into a broker, that broker is responsible for routing that information to interested parties. And what's neat about this, it's kind of a star topology. It's a hub topology. Clients who are looking for information and, for example, devices who are providing it don't have to know anything about each other really, except for how to talk. And it really simplifies a lot of things in the world of industrial automation and control, in particular home automation, which is where it's seeing a lot of use right now. One of the neat design features of the protocol is it's super lightweight. It was designed for low bandwidth connections. It was created by Arlen Nipper and Andy Clark back in '99 for applications in the oil and gas industry. They were managing pumps and valves and pipeline data, and their backhaul was satellite, and they charged by the byte. And so they were really looking for something that would be very lightweight and reliable at the same time. I mentioned before that Eclipse Foundation is involved, as well as Oasis, and it's been a very successful protocol since '99, and it's practically an overnight success if you look at it in Jeff Bezos' years. His philosophy is it's 10 years for any new technology to really take off. Here's how this overnight success went. It's out in the world now. It's in Amazon, AWS IoT Core. It's in Microsoft's offering as well as Google Cloud. It first got a toehold in Facebook Messenger. They were having trouble with scalability and traffic, and adopted MQTT as their messaging routing system. And that's really where it really began to take off. I'm going to talk today about inductive automation and Cirrus, two companies that are involved in the SCADA / industrial automation markets. Cirrus provides modules that provide MQTT functionality into Inductive's ignition project, and I'll talk about that in a minute. But what inductive automation has done is they've made a business on hooking up all kinds of disparate devices that are used in factory automation and plants, and providing a kind of an overarching dashboard interface for folks, so process engineers can see how all their stuff is getting along in real time, even over very wide area networks. Let's do a little quick rundown of how MQTT works so we can sort of see where Sparkplug comes into play. Picture you have a bunch of temperature sensors that are hanging off of your network somewhere, and they all can provide data. We have an MQTT broker on our land somewhere and a number of interested parties who want some or all of that information that's coming in off of that sensor network. And so clients can register to ask for certain kinds of information that come in on what we call topics. So these two guys want any and all information that starts off with a temperature topic. And this guy down here, he just cares about stuff coming in off of temperature sensor number 2. Now, it's important to note that these clients don't have to be SCADA control systems. They could be something like, a business process system for tracking work in progress. It could be for, tracking volume for sales projections. I mean, a whole bunch of different business systems can hook into something like this. So temperature sensor number 1 comes in and publishes on his value, and it immediately gets routed by the broker out to the two parties who want everything. Now, since the last guy down here on the lower right only subscribed to data from temperature number 2, or temp sensor 2, he doesn't get anything. And so when temperature 2 comes along, he publishes his value, and everybody gets the message forwarded to them. And so this architecture is pretty cute. And one of the things to note about it is the sensors on the left-hand side of the screen don't know anything about the clients, and they're never accepting connections from the outside world. They're just connecting into the broker. And they only need to know one IP address, and they never take in outside connections. So there's almost built into the system a certain level of security, which is kind of nice to see. Plus, it's riding on top of TCP/IP, and that gives you all the advantages of SSH and TLS and the other security measures that have happened so far, and maybe will be happening in the future as well. So there's some neat pros for MQTT. It's really easy to set up. It's just sockets over TCP/IP. You've got all the advantages of TCP/IP security. And again, back to the earlier point about clients, the devices don't have to know who the clients are or where they are, and so there's no problem there. And by virtue of the fact that this has been around for a long time and has been exceedingly popular, there's a huge developer network out there to pull from, and a lot of expertise out in the world. Those experts have gone on to build all kinds of interesting libraries and supporting infrastructure for embedded devices, and so there's this huge corpus of stacks for MQTT in different microprocessors. Now, those are a lot of the pluses. Some of the minuses are that you need to know the namespace and the topics that are available from devices that are on your network. And so there's some prior knowledge that you need to have in order to get the system up and running properly. I mentioned before the lightweight aspect of this protocol was part of the design. It can get taken over pretty quickly if you have a wordy topic space or you have complex data that you might find yourself, wanting to have on more modern networks that actually have some bandwidth. And so it's something that has to be paid attention to. And then finally, the problem with MQTT really is that there are no standardized payloads. And so in some sense, it's an architecture that people bought into and some protocol structure, but what's running over that protocol is pretty much anybody's guess. So when you're talking to one vendor or you're talking to another vendor, you don't really know what the other guy's going to say without digging into their implementation. So this is kind of where the Eclipse Foundation jumped in, along with Cirrus Link as well as inductive automation, and developed the Sparkplug standard. And this is a topic and payload definition for MQTT messages. So really, it's just riding on top of MQTT, and it gives us some interesting things. It says, okay, well, let's just discover devices on the network. So who's out there, and more importantly, what can they do? The protocol defines ways to publish your topics to say, this is what I know how to talk about, so that people who are listening for that information can then appropriately respond and ask for what it is you can deliver. In addition to topics, you also have additional metadata that you can include, such as engineering units and valid ranges and all kinds of things that are handy in industrial control contexts. Again, they're also moving toward standardized payloads, and by virtue of their using Google protobufs, we now have a compression scheme that really decreases the bandwidth requirements of Sparkplug. And so that's a nice feature of that. And what's nice from the standpoint of people who do industrial automation is that this now, with the Cirrus Link MQTT modules integrated, slots right into ignition and makes Sparkplug aware devices something that this community really can easily take advantage of. I mentioned Ignition a second ago. It's a very highly successful SCADA and industrial control application platform. Been around for a long time, and they talk to everybody. All the different vendors who provide, pumps and valves and switches and anything to do with, process control are supported by Inductive. It opens the door for a whole bunch of other companies to get slotted into this infrastructure in a very easy way. So I'm going to try showing you how we're doing RFID with Sparkplug. And I mentioned earlier the work we've done at Digame with SensThys Corporation. We're going to start with one of their RFID readers. And let me show you two of them. This is the SensorArray family. I mentioned it earlier. This is a neat integrated RFID reader and antenna. It's PoE powered. And the neat thing about this family is they not only have power, they can have power on PoE, they can route data and power between each other. So one reader can power up to 23 other ones, given the appropriate PoE supply back in the hub. So that's an interesting networking feature. The other one that I mentioned earlier is the Extreme platform, which is the ruggedized industrial version of a reader that's also PoE powered and has a load of different kinds of sensors on board, including PoE, Wi-Fi, GPIO, Bluetooth, 3-axis accelerometer, GPS system, barometric pressure. I mean, it's got everything in there. What we're going to do today, though, is show you how we're going to take one of these systems and hook it into Sparkplug. And so here we have a number of RFID readers that are sitting on our network, and we have a small embedded PC running some Sparkplug edge node code that we've written that speaks on one side the proprietary TCP/IP protocol that the SensThys readers use, and packages up that information and provides MQTT Sparkplug messages compressed with protobuf to the Cirrus Link solutions engine. And that engine then communicates with Ignition and allows us to take advantage of these devices within the Ignition user interface. We'll show you that here in a minute. Let's take a look.